Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0105 indicates there is an issue related to the manifold absolute pressure MAP sensor in the Honda Pilot models from 2016 to 2022. This code specifically means that the MAP sensor is out of its expected voltage range, which is crucial for calculating engine performance and air-fuel mixture. The MAP sensor is a vital component located in the intake manifold, generally found attached to the throttle body or near it. Its role is to measure the pressure inside the manifold and provide that data to the Powertrain Control Module, PCM, for proper engine management. When the PCM detects a voltage signal from the MAP sensor that falls below or exceeds predefined thresholds, it triggers the P0105 code. Understanding this code is essential because it can significantly impact engine performance, fuel efficiency, and emissions control. The MAP sensor measures the intake manifold pressure, which is crucial for the PCM to calculate engine load. Located in the intake manifold, this sensor is typically mounted on or near the throttle body for optimal performance. The sensor sends voltage signals to the PCM based on the current manifold pressure. These voltage signals have specific thresholds to ensure accurate readings. Signals below 0.18 volts or above 3.43 volts indicate problems. It's important to note that these values are the operational limits set by the manufacturer for the MAP sensor's normal functioning. Therefore, any deviations can raise the DTC P0105, alerting the driver to an issue that could result in poor engine performance or increased fuel consumption. Understanding these locations and functions is key to troubleshooting the DTC. Several factors can lead to the P0105 code being triggered. A defective MAP sensor may fail to provide accurate voltage signals, causing the PCM to react incorrectly. Open circuit issues can disrupt the signal transmission between the MAP sensor and the PCM, leading to voltage readings that are out of range. If wires are shorted, this can also cause the sensor to send erratic signals to the PCM, further complicating the troubleshooting process. Additionally, poor connections or loose terminals can lead to intermittent failures that may not be present during every instance of vehicle operation. This unpredictability makes diagnosing the problem even more challenging. But recognizing these potential causes is the first step to effective troubleshooting. When the P0105 error code is active, it can manifest a range of symptoms that significantly affect driving and engine performance. You may notice poor engine performance, which can indicate that the engine is not receiving the correct air-fuel mixture due to inaccurate pressure readings from the MAP sensor. Consequently, this inefficiency often leads to increased fuel consumption as the vehicle attempts to compensate for the misunderstanding of engine load. Additionally, the check engine light CEL will likely illuminate on your dashboard, alerting the driver to an existing issue. Ignoring these signs can lead to further complications, such as reduced drivability or even engine stalling. Thus, recognizing these symptoms early can save time and resources in diagnosing the problem. In the initial troubleshooting step for DTC P0105, begin by turning the vehicle to the on mode. The next action is to use the HDS, or Honda Diagnostic System, to check the output of the MAP sensor. The HDS will display critical parameters and voltage levels, which need to fall within specified limits for normal operation. Check if the MAP sensor reading is below 0.18 volts, as indicated in the fault code analysis. If the reading confirms this, then the failure has been replicated, and troubleshooting progresses to Step 3. If it does not match, proceed to Step 2 for further diagnosis. It is crucial to follow these steps accurately to ensure precise troubleshooting and repair. In this second troubleshooting step for DTC P0105, again turn the vehicle to the on mode to assess further. Once activated, check the map sensor parameters with the HDS. In this case, you will be verifying if the map sensor reading exceeds 3.43 volts. If this condition is met, this means that the failure can be reproduced, and the next step is to follow step 7. However, if the threshold is not met, it may indicate an intermittent failure, suggesting the system could be functioning correctly at this moment. In such instances, examine the connections, look for poor connections, or loose terminals at both the map sensor and the PCM. Referring back to the onboard snapshot of the DTC can help to recreate the conditions that triggered the fault code, facilitating diagnostics. The third troubleshooting step for DTC P0105 requires turning the vehicle to the off position before proceeding. After ensuring the vehicle is off, disconnect the map sensor's 3P connector. With the sensor disconnected, turn the vehicle back to the on mode again and check the voltage parameters using the HDS. Specifically, you're verifying if the map sensor voltage registers below the 0.18 V threshold. If it does, you will move on to step 6 for further analysis. Conversely, if the reading is above this threshold, you can safely proceed to step 4. This methodical approach helps isolate the issue, focusing the diagnostic efforts on specific components. During the fourth troubleshooting step for DTC P0105, your goal is to measure the voltage between two specified test points in the map sensor's 3P connector. With the vehicle in the on mode and the map sensor disconnected, use appropriate testing tools to check between the first and second test points. You will be looking for a voltage close to 5.0 V. If the voltage is approximately 5.0 V, this confirms that the signal is reaching the map sensor properly, and you're directed to move to step 5 for additional testing. However, if you do not find the expected voltage, it's time to replace the map sensor since it indicates that the sensor may be faulty and unable to deliver proper readings. In step 5 of troubleshooting DTC P0105, begin again by turning the vehicle to the off position. After the vehicle is off, it's crucial to jump the SCS line with the HDS and wait for a duration of more than 1 minute before proceeding. Now, disconnect the PCM connector, specifically the C51P connector. The next action involves testing for continuity between 2 points to determine the integrity of the VCC1 wire within your system. During this, it's vital that both the map sensor and the PCM remain disconnected to ensure accurate readings. If continuity is present, then congrats! The VCC1 wire is functioning correctly. However, if there is a lack of continuity, repairs on the VCC1 wire between the PCM and the map sensor need to be executed for a successful diagnosis. The sixth step in troubleshooting DTC P0105 requires you to turn the vehicle's ignition to the off position once more. Next, utilize the HDS to jump the SCS line and wait for over a minute. Following this, disconnect the PCM connector C51P for further testing. The focus here is to check for continuity between the second test point of the map sensor connector and the body ground. This step gives insights into whether the PB line experiences any short circuits impacting its function. If continuity is confirmed, the PB wire is functioning correctly. If not, then action is needed to resolve any shorts in the PB wire between the PCM and the map sensor before moving forward with your diagnosis. In the seventh troubleshooting step for DTC P0105, begin by having the vehicle turned off. Next, Reconnect the map sensor's 3P connector before moving on to further testing. Utilizing a jumper wire, connect terminals A and B on the map sensor connector, allowing the test to assess functional voltage levels. With the vehicle turned back to the on mode, measure the voltage values using the HDS. This ensures that the readings from the map sensor are influenced correctly through the jumper connection. Ideally, you want to confirm that the readings now exceed 3.43 V. If they do, proceed to Step 8 to continue the diagnostic process. If they do not, replace the map sensor, as this indicates a faulty component that requires immediate replacement. During the 8th troubleshooting step for DTC P0105, begin the process by turning the vehicle off again. After this, remove the jumper wire from the map sensor 3P connector to restore it to its normal operation. Next, once the vehicle is set to the on mode, again, measure the voltage between the map sensor test points to ensure they align with expected values. This further testing aims to confirm that no voltage drops occur under normal operational conditions. You'll want to verify that you see approximately 5.0 V at the sensor's output. If this reading is accurate, then move to Step 10 to investigate further. If not, proceed to Step 9 to check for issues along the SG1 wire. In this 9th troubleshooting step for DTC P0105, first turn the vehicle to the off position once more. Next, jump the SCS line using the HDS and allow it a minute for stabilization. After that, disconnect the PCM connector C51P. Focus your attention on checking for continuity between the first test point on the MAP sensor connector and the PCM's corresponding connection point. Ensuring there is continuity verifies the SG1 wire's health. If continuity is confirmed, the SG1 wire is functioning properly, but additional checks may be required. If continuity fails, this indicates an open wire scenario, which necessitates repair of the SG1 wire between the PCM and the MAP sensor to resolve the DTC. In the final troubleshooting step for DTC P0105, once again, ensure the vehicle is turned off. Following that, jump the SCS line using the HDS and allow it to stabilize for over a minute. The next step involves disconnecting the PCM connector C51P. This time, you will check for continuity between the second test point of the map sensor connector and the PCM's connection point. If continuity checks out, then the PB wire is operational and may not require further investigation. However, a lack of continuity will necessitate prompt repairs to resolve any issues with the PB wire between the PCM and the map sensor. It is vital to ensure that all connections are sound before concluding the troubleshooting process to avoid recurring DTCs. After completing all necessary repairs concerning DTC P0105, it is crucial to engage in final repair verification. First, conduct a retest of the DTC P0105 to confirm that the Diagnostic Trouble Code is no longer active. Follow this by verifying that the map sensor is functioning correctly, ensuring that it outputs appropriate voltage levels and communicates efficiently with the PCM. It is also vital to inspect that all connections are secure and that no loose ends remain, as this could trigger the DTC again. Furthermore, take note of any lingering symptoms to ensure overall vehicle performance remains optimal. Once all these points are confirmed, the DTC P0105 issue may be considered resolved, and routine monitoring should follow. To prevent issues similar to DTC P0105 from occurring in the future, routine maintenance checks of all sensors, particularly the map sensor, are essential. Regularly inspect all wiring and connectors for signs of wear or damage, which could lead to connectivity issues. Especially pay attention to areas where wires may be exposed to heat, moisture, or vibrations, as these factors can accelerate failure. It's also wise to address any signs of corrosion at connectors promptly. Keeping the engine bay clean can also help minimize the risk of contamination that might affect sensor performance. By implementing these proactive measures, you can greatly reduce the chances of DTC P0105 reappearing and enhance overall vehicle reliability. In conclusion, understanding DTC P0105 is crucial for maintaining optimal engine operation within the Honda Pilot from 2016 to 2022. This code specifically points to an issue with the MAP sensor being out of its expected range, impacting engine performance, efficiency, and overall drivability. Ensuring that the MAP sensor and related wiring are in good condition is vital for accurate engine management. The troubleshooting steps outlined provide a systematic approach to diagnosing and resolving the issues, emphasizing the importance of verifying connections and sensor function. Finally, engaging in regular preventive maintenance can help mitigate the risks of future occurrences, maintaining the health and longevity of your vehicle. Being diligent about these factors not only resolves issues promptly, but also enhances your driving experience. Please like and subscribe to the channel. See you next time.